Welcome friends, in this video we are going to look at the mathematics paper 1 for the year 2019 and we are going to begin with question 16a, where we are told to find the sigma of 3x squared plus 8x minus 5. Then we close the brackets, dx. So we are finding the integral of the given function. So we're going to write the expression, then in brackets we have 3x squared plus 8x minus 5, then dx. So what are we supposed to do? Whenever we are integrating, we are going to add the power, 1 to the power, then we divide by the same results. So let's begin. This is 3x squared, we add plus 1 over the same 2 plus 1. Whatever you do to the power must also be done as a denominator. Then this is 8x raised to the power 1, so we do the same. It's 1 plus 1 divided by 1 plus 1 minus what happens to the constant. So the constant, you attach x or you multiply by x. So in our case, negative 5 times x will give us negative 5x plus c. Whenever we are dealing with the definite integral, we add the constant of integration. Then let's see how we can simplify. So we have 3 over 3 times x raised to the power 3 plus 8 over 2 times x raised to the power 2 minus 5x plus c. Then we can cancel. We have x cubed plus c, 2 here is 1, 2 here is 4x squared minus 5x plus c. So this is our integral. Now we move on to question B. The diagram below shows two triangles A and B. Describe fully the single transformation which maps triangle A onto triangle B. Since the mapping is done on triangle A, giving us triangle B, our triangle O is our object. I mean our A is object, then our B is image. Then if you look at what has happened, the shape of the image is the same as the shape of an object, the size is the same. Then if you look at the corresponding sides, they are facing in the same direction. So there was just a movement of this object giving us this image. So we are dealing with translation. Now what are we supposed to have whenever we have translation? So under translation, first we are supposed to find the translation vector, then we can give the description. Now let's look at the formula for translation vector. So the formula is this one: translation plus the object must give us image. Then if we make t the substitute formula, we get I minus O. So what we mean by this, so let's say at this point we have A, then here we are going to have A image. So let's get the coordinates of A. So at this point is 4, 4. Then what's our A image? A image is negative 2, 6. So we can use this to find the translation vector. So we say t is equal to, the image is negative 2, 6 minus, then we have 4, 4. Then t is equal to negative 2 minus 4. We have 6 minus 4. Then if we simplify our final answer, we get negative 6. Then we have 2 here. So 4 from 6 we get our 2. Let's see if we can get the same answer. If let's say we use this pair, so let's use this pair. We'll say B, then we have B image. So the B object is 4, 1. Then the B image is negative 2, 3. So let's see if we can find the same answer. So we have translation vector is equal to image minus object So we begin with the image, which is -2, 3 minus, our object is 4, 1. So t is equal to -2 minus 4, then we have 3 minus 1. So what do you get on top? On top we are going to get -6, since the same sign we add. 3 minus 1 will give us 2. So we can see that we are getting the same answer. So the concept behind finding the translation vector is you need to get the coordinates of the image, you subtract the coordinates of the object, then you got the translation vector. Now after we have our translation vector, we can now give the description. So we'll say triangle A was mapped onto triangle B by translation with a translation vector of, we have -6, 2. So this is our final answer. We move on to question 17. Under question 17, we are given a triangle, and the concept that we are going to use is a concept of bearing. So we have question 17. In the diagram below, A, B and C are 3 points on a level ground. The bearing of B from A is 62 degrees and angle ABC is equal to 128 degrees. C is due east of A. Then this point is very important. We are told C is due east of A. It means the line AC is meeting this line at 90, or we can say they are perpendicular to each other, which means that this angle must be equal to 90. As long as you have due east of something, then the angle between those two lines must be equal to 90. So if this angle is 90 and the inside is 62, how can we find this angle here? So we can find this angle by subtracting 62 from 90. So let's do our math. So we have 90 minus 62. So 0 minus 2 is impossible, so we get 1 from 10. I mean 1 from 9 giving us 10. 10 minus 2 is 8. Then here we have 7. Not 7 but 8. So 8 minus 60 will give us 28. So here we have 28 degrees. Where else can we can also find this angle, right? So we know that a triangle adds up to 180. So let's put this is angle X. So say X plus 28 plus 128 is equal to 180. So 28 plus 128 will give us 156, which is equal to 180. Then we get the 156, we move it to the right side. This will give us negative 156. Then 180 minus 156 will give us 24 degrees. So where there is X here, we have 24. So it's better, or maybe you can start by going to the question, or if you want you can first fill up the missing angles. So after we are done, let's now go to the question. Find the bearing of the first one, C from B. C from B. So it is coming from B. So where it is coming from, you need to draw a vertical line in case where you are given. So you are going to draw this line, and this line that I'm drawing is the one that we are going to consider as line B. So this is our line B. So if this is line B, then this is our line C, because these two lines are meeting. So after you identify the line where the bearing is coming from, then you need to start north of that line. So in our case, we are starting from any point above B. So we need to move in a clockwise direction. So this is the angle that we are we are solving for. Now the question is, what angle is this one? How can we find this angle? So this is what we are now going to do. So with the mathematics, what we know that the straight line here is equal to 180. So this is the angle 180, and if this is angle 180, and we know that this line and this line, they are perpendicular, so here we have 90. So if we have 90 plus 24 minus 180, we can find this angle. Then this angle subtract from 180, we have the angle that we want. So we'll say 90 plus 24 is giving us 114. Then this 114 will subtract this one from 180. It will give us the angle that we want. Or to summarize, if one, we can just say 90 minus 24. So this will give us 66. So that is the angle, the bearing, which is 66 degrees. Now away from there, we go to question B, where question B, we want the bearing of A from C. So this time the bearing is coming from C. So we need to draw another vertical line passing through point C. Then we put our north. So remember, this line represents the C. Then the original point C is here. Then we are saying we need to move in this direction. Then we are going to A. So we move in a clockwise direction until we touch line A. Now we are saying at this point, this should be, I think, let me first sketch it of this. I think I made a mistake on this one. This shouldn't be this angle. So here we are supposed to have 66. Then 180 minus 66. 180 minus 66 will give us this should be 114. So this is the angle here. It's 114, not that one. So if this angle is 66, then this angle must also be 66, because we know alternate angles are equal. So here we have 66. So 66 plus 24 will give us 90, which means this angle is equal to 90. And it's making sense because this line and this line are perpendicular. So this is 90. So 360 minus 90 is 270. So this is our angle of consideration. So this is how we can find the missing angle. We move on to question 18. So question 18a, the diagram below shows a plane figure made up of congruent semicircles, angle A or B. So congruent, it means they have the same length as well as same angles if we are given angles. Now if they are same length, we can say the shapes are the same and the sizes are also the same. Now let's look at the question. Describe fully the symmetry of the figure. So the description under rotation, we need to find the order of rotation. So order of rotation is how many times this can rotate to go back to its original position. For example, point A. How many times can we rotate point A to go back to this position? So remember, these shapes are the same. So if these shapes are the same, then each rotation will fit. So if this A goes on this one, it will fit. Then 2, 3, 4. So the order of rotation is equal to 4. Then after we found the order of rotation, let's look at the angle of rotation. So how do you find the angle of rotation? Is equal to 360 divided by the order, which is giving us the angle 90. Then to finalize our answer, we can just say a plane figure has an order of rotation 4 and angle of rotation is equal to 90. So under the description of rotation of figures, you just have to make sure that you include the angle of rotation as well as the order of rotation. So that's what you're supposed to do. Okay, so we move on to question B. So in the answer space below is an incomplete program written in pseudocode form. Calculate the volume of a cuboid. So we want the volume of the cuboid given the length. So the length is the input, base is also an input, and the height. Complete the program by filling in the blank spaces with appropriate statements. Alright, so we need first to write the formula. So for a cuboid is L times B multiplied by H. Then so enter length, then breadth and height. These are our inputs. Then where there is V, we need to make calculations. So it's L times B multiply by height. So that's our answer. Now we move on to question 19. The functions f and g are defined by f of x is equal to x minus 3, g of x is equal to 3x. Find f of inverse of x. So we begin by writing the expression for f of x, the original. So it's this is equal to 2x minus 3. So we replace where there is f of x by y. Then we have 2x minus 3y. Then from there, we need to make x the subject of the formula. So 2x minus 3 is equal to y. So there is nothing that I've done here. I just want to begin with 2x minus 3. Then what do you do? We need to move our negative 3 to the right side so that we remain with 2x is equal to y plus 3. Then to isolate x, we divide by 2. Also here, we divide by 2. Our final answer, x is equal to y plus 3 divided by 2. Then we just have to write the expression, which is the f of inverse of x is equal to. Then where there is y, you replace back with x plus 3 divided by 2. So that's our answer. Then for B, we want g of f of x. Here we want the composite function, so we are supposed to combine the two functions, making it one. So we have the outside function is g, then the inside function will be f. So the same pattern, first you begin by writing the outside function g, you open brackets, then the inside f of function must be here. So as usual, you write the outside function with its corresponding value, 3x. Then where there is x is where you are going to put 2x minus 3. So to simplify our answer, we are saying 2x minus 3. Then if we expand, 3 times 2x will give us 6x. 3 times negative 3 will give us 9. So which is this is our final answer. Then g f of 2. So let's say we ignore the 2, we assume we have an x here. So it's g f of x is equal to. Do you see that this expression we've already done it? So this means that the function of the composite that you formed is the one that you are going to use now to find the actual numerical value. So the expression is equal to 6x minus 9. Now, whenever we are given a value, it means the value of x is equal to 2. So where there is now x, we put 2. So this becomes 6 times 2 minus 9. So 6 times 2 is 12 minus 9. 12 minus 9 will give us 3. So that's our final answer. We move on to question 20. In the diagram below, A is the point 0,4 and B is the point 2,0 and O is the origin. Find the equation of the straight line through O, which is parallel to the line AB. So the equation of the straight line is given by this formula: y minus y1 is equal to gradient, open brackets, x minus x1. Or if you want, you can use y is equal to mx plus c. So it depends on the one that you are comfortable with. So now, the equation that we want, let's say this is equation m. Then the equation that we want, we call it equation n, is parallel to this equation. So if this is parallel, it is passing through this. We are told it is passing through the origin. So this is our equation. Now, remember, whenever two lines are parallel, then they have the same gradient. So that is the concept that we are going to use. Since we have the coordinates, since its origin, the coordinates will be 0, 0. But do we have the gradient? No, we don't have the gradient. So what are we supposed to do in our case? So what we are supposed to do is we are going to find the gradient of equation m, since we are given the coordinates. Then the same gradient is the one that we are going to use for equation n, since the two lines are parallel. So we'll say m is equal to 0,4 x1 y1 b 2,0 x2 y2. So gradient is equal to y2 minus y1 over x2 minus x1. So what is our y2? 0 minus 4 over x2 is 2 minus 0. We have on top negative 4 over positive 2, which is negative 2. So this is the gradient of this line. So since this line is parallel to this line, then they have the same gradient. So this is the number that we are going to put here. So we can now finalize our answer. Y minus c, where there is y1, we put 0. This is our y1. Gradient is negative 2, x is 0. I mean x, this one is just remains like this, then x1 is 0. Then if we subtract 0 from y, you see y. Then negative 2 times x is negative 2x. Negative 2 times negative 0 is just 0. So this is our final answer. We move on to question B. The heights of two similar cylinders are 4 centimeters and 6 centimeters. If the volume of the smaller cylinder is 48 cubic centimeters, find the volume of the larger cylinder. Right, so say we have smaller cylinder to larger cylinder. Now we have the two heights. The smaller has 4 centimeters. The larger one has 6 centimeters. So the first step that we are supposed to do is we need to make these numbers as ratio. So we divide by 2 centimeters, even here by 2 centimeters. So you need to choose a number that is common, or that can go into the given numbers without leaving a remainder. So we can cancel this. 2 into 4 is 2. Then 2 into 6 will give us 3. So these are known as scale factors. Now, what are we supposed to do if we are dealing with volume? So we know that volume is raised to the power 3. We are going to raise our factors to the power 3. That's what we are going to do. So 2 raised to the power 3 is 2 times 2 times 2, which is giving us 8. 3 raised to the power 3 will give us 27. So after we have found the volume ratio scale factors, we can now proceed. So the volume of the smaller is given 48. So you write where there is this, so 48. Then here we put x, we cross multiply. So 8 multiplied by x is 8x. Then in paper 1 where you don't have a calculator, for numbers like 48 times 27, do not multiply, just let them remain like this. So 48 times 27 will be written like this. You see the reason. So you divide by 8. Here we can just divide by 8 here. So we'll say 8 into 8 is 1. Then 8 into 24 is 3. 8 into 48 is 6. So we have 6 centimeters cubed multiplied by 27. Then we do this multiplication. 6 times 7 is 42. We keep the 4. 6 times 2 is 12 plus 4. So the final answer is 102 cubic centimeters of the larger cylinder. We move on to question 21. Write down the 3 inequalities that define the unshaded region area of the diagram below. Right, so we'll say this is inequality number 1, number 2, number 3. So for number 1 it's simple because it is just cutting one axis, and from the numbers it is cutting the y-axis at 6. So we'll just say inequality number 1, y passing through point 6. Then the above is greater, then here is less. Then the shaded is considered to be unwanted, so the greater is not the one that we want because it's shaded, so we want the less. So we put less than or equal to. So that's our first equation. Then our second equation will be, since it's slanting, we need to find the gradient. The first step is find a gradient. So the first pair of coordinates, it's 2, 0. The second one is 8, 6. So say x1, x2, y1, y2. So we know that gradient is equal to y2 minus y1 divided by x2 minus x1. So y2 is 6 minus 0 divided by 8 minus 2, which is the gradient is equal to 6 minus 0 is 6 over 4. So if we reduce these numbers, will give us 3 over 2. That's our final answer. This is our final answer in terms of the gradient. Now we need to find the equation of the straight line. So we say y minus y1 is equal to gradient. Then we have x minus x1. Then we can now proceed. So we can use n pair of the 2. So let's use 2, 0. So if you use 2, 0, it's y minus 0 is equal to 3 over 2 times x minus 2. So y minus 0 is y. Then 3 over 2 times x is 3 over 2 x. Then 3 over 2 times negative 2 is just negative 3. This means that 3 over 2 times negative 2. So this will cancel. So this is our equation. Okay, let's say we use the other pair to just clarify. I just want you to see something here. Right, so we say y minus y1 is equal to gradient x minus x1. So if we use this pair, we have y1 is 6 is equal to 3 over 2 multiplied by x minus what's our x is 8. So if we simplify, we get 3 over 2 times x is 3 over 2x. then 3 over 2 times the negative 80, this will give us negative 12. Then if we collect the like terms, if this shift to this side, this will give us y is equal to 3 over 2x minus 12 plus 6. So giving us y is equal to 3 over 2x minus 6. So we are supposed to get the same answer. Okay, so I made a mistake when finding the gradient. Sorry for this. So the gradient is not right. So the key point is we are supposed to get the same answer. So it's supposed to be gradient, since we are subtracting 2, it's 6 over 6, which is 1. So that is the correct gradient that we are supposed to use. So let's check now. Since the gradient is now 1, we are supposed to get the same answer regardless of the pair that we use. Okay, so we say y minus y1 is equal to gradient x minus x1. Then, okay, what is our y1 is 0 minus 1 x minus 2. So y minus 0 is y, then 1 times x is x, 1 times negative 2 is negative 2. So if we use this, we get this one. So let's check for the other one. So y1 is 6, 1, then x minus 8. So if we do the math, we know it's y minus 6 is equal to 1 times x is x, 1 times negative 8 is negative 8. So if we collect the like terms, we get y is equal to x minus 8 plus 6, which is y is equal to minus 2. Yes, this is the actual answer. So after we are done with that one, we can now proceed. So since we are solving for this one, the upper is greater, then here is less, and we want the less, and the line is dotted. Then our final answer is y is less than x minus, greater than, since we want the greater, so it's greater than x minus 2. So this is our final answer. Then we can find the last one. So the last one is 0,6, 2,0. So begin by finding the gradient, y2 minus y1 over x2 minus x1. So y2 is 0, x2 is 6 over, x2 is 2 over this one, so which is negative 6 over 2. Gradient is equal to negative 3. Then the equation is y minus y1 is equal to gradient x minus x1. So y1, if we use this one, is 6. Gradient is negative 3x minus 0, which is minus 6 is equal to, this will give us negative 3x, then plus 0, which is, if we take this to the right side, we give us y is equal to negative 3x plus 6 as our final answer. Now remember, the region that we want is greater, so we say now y is greater than or equal to negative 3x plus 6. So we move on to question 22. M is the point 0,5 and mn is equal to that, find or n. So let's see if we can make a visual diagram. So this is our origin. Then we put our m here, n here. then with these arrows. So this is the line MN, and we are given this vector is -3 and 4. Then we have OM. Yes, we have OM is 0, 5. So the question is, we want vector ON. So if we want vector ON, we move from vector O to M, then plus M to N. So let's do that. So ON is equal to OM plus MN. So ON is 0, 5, then here we have -3, 4. So you just have to do some math here. So it's 0 minus 3, 5 plus 4. 0 minus 3 is -3, then 5 plus 4 is 9. So this is our final answer. Then we go to question B. The sketch shown below represents the graph of the curve y is equal to x squared minus 4x plus 3 passing through the points A, B, and C. So we have the quadratic equation. Now find the coordinates of the points B and C. So B and C, these are just the x-intercepts. So you can use the quadratic formula, or if you want you can use the factorization. So it depends on the method that you are comfortable with. So let's write the equation. So the equation is y is equal to x squared minus 4x plus 3. So let's use the quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. So the value of a is the coefficient of x squared, b, then we have c. So let's do substitution. So b is -4. Then what's our a? Is 1, our c is 3, divided by 2 times 1. So negative times negative, we have +4. Negatives 4 squared is +16 minus 4 times 1 is 4 times 3, 12 over 2. 16 minus 12 will give us 4 over 2. The square root of 4 is plus or minus 2. Then we just have to split this into 2 equations. So one will be 4 plus 2 over 2. Then the other one will be 4 minus 2 over 2. So if you look at this one, will give us 4 plus 2 is 6 over 2, which is x is equal to 3. Then this one will be 2 over 2, which is x is equal to 1. So we have two values, 3 and 1. So let's go back. And the answers are making sense because if you look at the two x-intercepts are all located on the positive x-axis, so they need to be positive. So if you look at this is 0, then this is our 1, this is our 3, because we'll be able to reach 1 before we get 3. So the coordinates of B is 1, 0. So always in the x coordinates, the y value is always 0. Now let's say we want to use the factorization method. So our equation is x squared minus 4x plus 3 is equal to 0. So where there is y, we put 0. Then we are supposed to find product is given by a times c. So the value of a is 1. So 1 times c, which is 3, is equal to 3. Then from there we need to find the sum. The sum is just the value of b, -4. Then factors. So let me give you a picture. If you have numbers like if the product is like the prime numbers, let's focus on prime numbers. So if the product is 2, 3, 5, 7, 11, if that is the case, then the factors are 1 and the number itself. So if the product is 2, then the factors are 1 and 2, 3, 1 and 3, 5, 1 and 5, 7, 1 and 7. So in our case, the products, the factors will be 1 and 3. Now since the sum is negative, we just assign the negative. So negative 1 plus negative 3, we get negative 4 as required. We can now proceed. So say x squared minus x minus 3x plus 3 is equal to 0. So we factorize the first part, x is common, x into x squared is x into x is 1. Here we have negative 3 into negative 3x is x, negative 3 into positive 3 is negative 1. So we can see that these two are equal, are the same. So we factor 1. So x minus 1, then this one, we form the bracket, which is x minus 3 is equal to 0. Then we equate it to 0. So if we move our negative 1 to the right side, we get positive 1. Then if we do the same, we get positive 3. So we can see that we are still getting the same value. Then question Roman number 2, minimum value of y. So for minimum value, we just want the turning point, and under the turning point, we just want the value, the y turning point. So it's given by y is equal to, so y is equal to 4ac minus b squared over 4a. So remember, a is 1, c is 3, then our b is negative 4 squared over 4 times 1, which is, here we have 12 minus 16 over 4, giving us negative 4 over 4, giving us negative 1. So that is our minimum value. So let's see if it's making sense. So this is where our turning point is. So if you go in the y-axis, we are expecting to get negative 1. So this is making sense. Okay, so So 23, the diagram below is the speed time graph of a car. The car starts from rest and accelerates uniformly at 2 meters per second squared for t seconds until it reaches a speed of 16 meters per second. It then travels at 16 meters per second for 40 seconds, after which it comes to rest in further 10 seconds. Alright. So the first question is find the value of t. Now let's look at the data. So from the first point, acceleration is given 2 meters per second squared. Then final velocity is given. So the final is gotten from here, which is 16 meters per second. Then what's our t? T is not given, is equal to t. So question mark. What of our initial? Initial is here, is 0. So the initial is just where the line is starting from. So from the equation, we use this equation. Final velocity is equal to u plus at, which is our final is 16. Initial is 0. Plus the acceleration is 2 multiplied by t. So 0, we can just cancel this. 2 times t is 2t over t over 2. So our t is equal to 8 seconds. So at this point we have 8 seconds. Then remember, it then travels at 16 meters per second for 40 seconds. So from this point up to this point, the time elapsed was 40 seconds. So at this point we are supposed to get 48 seconds, so we add. So that's what you're supposed to do. What of this point? Then we are told after which it comes to rest in a further 10 seconds. So at this point we are supposed to get 58, since it's the addition of 10 seconds. Now question B, distance traveled in the last 50 seconds. So where is the 50 seconds? So the 50 seconds, if you look at this point, if you subtract this 8 from 58, we get 50. So the 50 seconds is this distance that we want. And from the shape, we have a trapezium given by this formula. So the distance is equal to half a plus b multiplied by h. So half, where is the value of a? So the value of a is this line on top. So if we move down, this is giving us 80, then here we are getting 48. So the difference between 48 and 8 is 40. Plus c, the value of b is this distance up to here, which is 58 minus 80 is 50. Then the height is this line, which is 16. So 50 plus 40 is 90, plus 2 here is 1, 2 here is 8. So 8 times 0 is 0, 8 times 9. So 8 times 8 is 64, 64 plus 8 is 72. So the distance is 720 meters. Then you see the speed of the car when t is equal to 53. So under this question, we need to think. So first let me get rid of these. So 53, when t is equal to 53, somewhere here. So this is where our t is equal to 53. Then what are we supposed to do? What we're supposed to do is we are going to draw the line from the point where we consider to be 53. Then we touch the slanting line. Then we turn 90 degrees. So what I'm saying is this: you draw a line, then it moves. So we want the speed at this point. So if that is the case, what are we going to do? First, we are going to find the deceleration for this line. So let's call this one point A, B, C. So let's find the negative acceleration between A and C. So say acceleration is equal to final minus u over t. Whenever the line is touching the x-axis, or whenever an object comes to rest, the final is always 0. Then the initial is this number. So at this point, the initial will be gotten from here, then the final will be gotten from here. So 0 minus 16 over t. The time from 48 to 58 is what? Is 10. So acceleration is equal to negative 16 divided by 10. If we reduce, we get negative 8 over 5. So we can leave it as a fraction. Now we go back to this point. Remember, if the line is straight, then the acceleration is constant. So we'll say we have the acceleration between A and B. So can we find the final velocity? Yes, we can find the velocity. So the final velocity will be, final velocity is equal to initial plus AT. So if we get AB, then B is our final. So final is equal to initial is 16 plus the acceleration is negative 8 over 5 times the time at this point is 53. So what is the difference between 48 and 53 is 5. So V is equal to this 5 and this 5 cancel. So 16 minus 80 will give us 8. So the final answer is 8 meters. So to summarize, what I'm talking about is that the first one, find the acceleration of the whole line, the straight line. Then from there you pick 2 points of which 1 point is the point of consideration. So that's it for this video. Thanks for watching.